Hello everybody, welcome back to my channel. So today is day 2 of covering at least one p block compound every day on this channel, and today we're doing ammonia for day 1, which is dinitrogen. Check out the linked video to this shot. Now let's get started. So naturally ammonia is present near us in like soil and in air as well. It is formed by the decomposition of nitrogenous organic compounds. Let's say this is urea. This is a nitrogenous organic compound. When it decomposes, it forms ammonium carbonate and then eventually ammonia as well. On a small scale, it's formed when caustic soda and CaOH twice react with ammonium salts like ammonium sulfate, ammonium chloride. Like you can see these two reactions here. You get ammonia, you get CaCl2, or in this case Na2SO4. And now on a more commercial, a larger scale, Haber's process. So Haber's process is when dinitrogen reacts with hydrogen to form ammonia. Now we all know Le-Chatelier's principle, where high pressure favors the reaction goes towards a place where less number of gaseous moles are present. So that means it would favor the production of NH3. That's why this reaction happens at a pressure of 200 atm, like very high pressure in general, and the temperature is at around 773 Kelvin. Catalyst used here is iron oxide, and we also take Al2O3 and K2O, but previously iron was used as a catalyst and molybdenum was used as a promoter. Now properties of ammonia is that it's colorless like dinitrogen, but it has a pungent odor, unlike dinitrogen which was smell odorless basically. So it has a higher freezing point and boiling point due to hydrogen bonding, which it exhibits in both solid and liquid phase. You can look at the values, but I don't think there's any necessity to remember them by heart. Now, this is the structure of ammonia. It's trigonal pyramidal with a bond angle of 107.8 degrees. It's highly soluble in water, and the resultant ions are weakly basic. And because it's a weak base, it precipitates the hydroxides of some metals from their salt solutions like FeCl3, Fe or Zn. You get Fe2O3, which is a brown colored PPT, ZnOH twice, which is white. It is also a Lewis base because it contains a pair of electrons. Apart from this, it's also used in metal detection. Like for example, if you take Cu2 plus and perform a reaction of it with ammonia, you get this complex which is deep blue in color. So because there's been a color change, we'll be able to detect that this ion is actually present. Same for a reaction with AgCl. It also forms ammonium salts with acid.